Hi, in this video we are going over the first section of chapter 7, 7.2, estimating a population proportion. There's a problem. In a survey of 1,007 people, the reports tell us that 85% of the adult population, they know what Twitter is. So we may have the question, there's 325.7 million people in the US. How do we only use this much of 1,007 respondents to reflect the whole US population? And that is the question that we are trying to answer in this section or this chapter. The goal is to use a sample data to make inferences about a population, or we call that to be inferential statistics. And for this section, we use a sample proportion to make an inference for a population proportion. Now, a population proportion is just a parameter that describes a percentage value associated with a population. The first keyword here is the point estimate. A point estimate is the value used to approximate a population parameter. And we use the letter p hat, the p with the hat, to represent for the sample proportion, and the normal p is for the population proportion. And p hat is the best point estimate of the population proportion, the normal p. The way we calculate the p hat is that equal to x over n, and x is the number of the subjects divided by n, which is the sample size. Now let's consider the very first example on how to find the point estimate. A survey conducted at a local high school, and it's found out that 700 of 1,000 students used Facebook. Based on the results, find the point estimates of the proportion of all the students who use the Facebook. The point estimate is represented by the p hat, which is x over n, and x is the number of the subjects in question, dividing by the total n, which is the sample size. In this case, we took the sample size of 1,000 students, so n is 1,000, and only 700 of them respond that they use Facebook, so that is the number of the subjects in the question. So 700 divided by 1,000, which is 0.7. So 0.7 is the point estimate for this example. The next topic is the confidence interval, CI. Now, the confidence interval is an interval of numbers. We have the lower bound and the upper bound. That is the measurement of the likelihood that the interval contains the unknown parameter based on the point estimates. So after we figure out the point estimate, we need to figure out the confidence interval, which is some lower limit up to higher limit that tells us the likelihood that the interval contains the unknown parameter that we are looking for based on the point estimate. This gives you the low, the mean value, and the max value that contains the unknown parameter somewhere between that. And then the confidence level. The confidence level is just the probability that the confidence interval actually does contain the population parameters, and assuming that the estimation process is repeated for a large number of times. And we use the notation from the textbook, which is 1 minus alpha, and that is multiplied by 100% for the confidence interval. So the most common confidence levels: 90% confidence level. 90% is 0.90. 95% is 0.95 confidence level, and 99% confidence level is just 0.99. So we just convert them back to the decimal. Now the corresponding value of alpha, we use the level 1 minus alpha multiplied by 100 for the confidence interval here. So 90% confidence levels means that the other 10% is the probability of not getting the parameter inside the interval. That means alpha is the probability that the confidence interval will not contain the true parameter value. That's why 90% confidence level will give you the alpha to be the other 10%, because 90% and 10% is 100%, and 10% for alpha means 0.10. 95% confidence interval, that means the other 5% will not contain the true parameter, or the alpha should be 0.05. And 99% the same thing, which is the other 1% or 0.01 for alpha will not contain the true parameter. So let's say I have alpha to be 0.01. That means the confidence level is 1 minus alpha multiplied by 100%, or 1 minus 0.01 multiplied by 100%, that is 99%. Now it tells us that if there are 100 different confidence intervals are constructed, and each based on a different sample of the same population, then we expect that 99 of the intervals from that 100 different confidence interval to contain the true parameter, and one of the confidence interval does not include the parameter. So that is what it means for having a 99% confidence level. Now, 95% confidence level is the most common because it provides a good balance between the precision and reliability. The next word, the key word here is the critical values. We use the z alpha over 2 to represent for the critical values, and recall that a z-score is a number of the standard deviation from the mean a data point is. So if I have the z-score of maybe 2, that is 2 standard deviation from the mean of the data point. Now z alpha over 2 is just the value of the z-score on the standard normal distribution with the alpha over 2 area to the right. Okay, and this number is on the borderline. It separates the sample statistics that are likely to occur from those that are unlikely. So let's say consider this figure. Z equals 0 is just the middle of the picture, and z alpha over 2, this is the critical value right here. So alpha over 2 is just the area, the red to the right, and then the other minus alpha over 2 here, which is also the one to the left. So the one in the middle here is the confidence level of 1 minus alpha. That's why we have 1 minus alpha multiplied by 100%. This is the confidence level. This is the region of the confidence level. And then 1 minus alpha, that means this half right and this half left, all together they make up one alpha. That means this is half of the alpha, and this is the other half of the alpha. And z of alpha over 2 is this value right here, is the critical value that we try to find here. Now let's try one example. Find the critical values z alpha over 2 corresponding to a 95% confidence level. So we are given that the confidence level is 95%. So 95% confidence level corresponding to the alpha of 0.05, because the other 5% is the alpha and 5% is 0.05, and therefore alpha over 2, 0.05 divided by 2 is 0.025, and this is just the red area to the right. So the alpha over 2, 0.025 is the area to the right of the z alpha over 2 here in this picture. So after you figure out alpha over 2, which is 0.025, This is the value to the right, the area to the right. And so the rest of the left of this value here should be 0.7975 because the whole thing should be 1. We know that this is 0.025, so take 1, subtract 0.025 for the red one. The whole blue one here to the left should be 0.975. And we are given the area. How do we figure out the z-score of that, which is z alpha over 2 right at this point? Now, we can go back to the positive z-scores and try to look for that. We know that now the area to the left, which is of what? 0.975. Because this value here, the value on the z-score is the area from the left of the value, the cumulative area from the left of the point, z here. So we know that we got the area to be 0.975, which is the blue one to the left of z of alpha over 2. So I try to look for the number 0.9750 from table A2, and I know that this is what? This is 1.9 and combining with 0.06, so altogether 1.96. So the z-score that's corresponding to the area of 0.9750 should be 1.96, or the critical value z of alpha over 2 should be 1.96. And then we can also find the critical value using the TI-8384 plus, just for a quick way to do that. All you have to do is hit the second and go to the verse, or which is the distribution, and then go to the inverse norms, and then enter the area to the left of the inverse norm command, and the area to the left of that, which is 0.9750, this guy here, and that should give you 1.96. Now DISTR is the distribution, and inverse norms is will compute the inverse cumulative normal distribution function for a given area under the normal curve. Now let me quickly show you how to use that here. Okay, so like I mentioned before, all you have to do now, let me turn on this one. Okay, clear. So the first step is that we click on the second. Let's put it this way. Okay, second and verse. So second and verse will take me to the distribution, and then we hit the down arrow until inverse norm. Click enter, and then the area, because this is only for the TI-83, but TI-84 they has a little bit different commands for the screen here. The one that you see here is for TI-83, but we can do the very similar thing for TI-84. Now they ask you for the area, that means the area to the left of the point you are solving, and that area is 0.9750. So I go ahead and hit 0.9750, and we always let the standard deviation to be 1, the mean to be 0, and all you have to do is click enter, 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 and then enter, and then enter here. So it gives you the value of 1.95996, which is very similar to here, the same thing. So we round it up to 2 decimal places, which is 1.96. So that is how you use the TI-84 plus to find the critical value. And this command here is only for TI-83. And doing the same process, we have the table to summarize the common value, the critical values for 95%, 99, and 90. So 95% Z alpha over 2 is always 1.96 and 1.645 for 90%, and for the 99% it's 2.575. Now the next word here is the margin of error, E. So what is the margin of error? The margin of error is the maximum likely difference between the observed sample proportion, and the true value of the population proportion P. So it gives you the maximum likely difference between the one that we observe for the sample proportion P hat versus the true parameter of the population P. Now the way we can find the margin of error E is that we take the Z alpha over 2, or the critical value, multiplied by P hat and then P hat and then Q hat, and divide by N. Let's write this here. So P hat and then Q hat divided by N. So that is the square root of that. Now P hat is the same P hat, and Q hat is what? Is just 1 minus P. It's just the complement of P. So because P hat and Q hat, they adding together equal to 1. So Q hat is just 1 subtract P hat, and N is just the sample size. Now for example, for a 95% confidence level, which is the alpha 0.05, so there is a probability of 0.05 that the sample proportion P hat will be in error by more than an E, or the margin of error. So that is what that means for the margin of error. Even though that we can make the confidence interval, but there's always an error, and that is the margin of error, which is the difference between the observed sample proportion and the true value of the population proportion. And that's why we use this one, the margin of error, to construct the confidence interval for the proportion P. Now, how do I construct the confidence interval for the proportion P? There are a few requirements for creating a confidence interval about the proportion P of psi n from a population of psi n, the big N. So N, the big N, is the size of the whole population, and the small n is just the size of the P hat, which is a sample size. Now, the first requirement is that the sample is a simple random sample. That means this is a subset of a statistical population in which each member of a subset has an equal probability of being chosen. It has to be random. Now, the second one is that it has to satisfy the binomial distribution, which is independent for all the trials, and you either get 2 cases, success or failure. And the third case is that it also has to satisfy the normal approximation to the binomial. That means there are at least 5 successes and at least 5 failure. Or we can just using this equation inequality to check for the requirement n times p times 1 minus p. It has to be bigger than or equal to 10. And again, the confidence interval is constructed from the margin of error. That means after we get the point estimate for P hat, all we do is we take P hat plus or minus the margin of error, because the margin of error is telling you how much we can move around the P hat, the point estimate, and that should be P hat subtract the margin of error, or up to the max limit of P hat add to the margin of error. So plus or minus E, that means the lower limit is P hat minus E, and P hat plus E for the upper limit. or the lower bounds, we know that p hat minus e and p hat plus e, and e should be the margin of error we got from the above formula, which is the critical value multiplied by p hat 1 minus p hat over n, and the same thing here, p hat 1 minus p hat over n. One is minus for the lower bound, the other one is plus for the upper bounds. Okay, let's try one example here to make more sense. Now there's a research center. They had 1,007 people randomly selected US adults, and it shows that 85% of the respondents knows what Twitter is. The sample results are N, which is the sample size, 1,007 people that took the survey, and the point estimate in this case is 0.85 because that is 85% of the sample, right? It's getting the results from the sample of 1,007 people. Now the first question, they ask you to find a margin of error E that's corresponding to a 95% confidence level. 95% is the common confidence level, so we are trying to use that in this example here. Before doing anything, we must check the requirement. So we know that this is 1,007 people randomly selected, so that is the simple random sample. So the first requirement is okay. The second one, this is a binomial distribution. Yes, because either that they know Twitter or they don't. So yes or no, successful or failure. And each person has an independent survey. So that is the requirement for the binomial distribution. The third one, we check for the inequality n p 1 minus p bigger than or equal to 10. So we know that n is the sample size 1,007 people. P is the p hat, right? P here means the same thing, p hat, because we are talking about the point estimate p hat. So n p hat multiplied by 1 minus p hat bigger than or equal to 10. And yes, p hat is the probability that 85% know what Twitter is. So that is the success p hat. And 1 minus p hat, which is 1 minus 0.85. And altogether, this number on the left side is bigger than or equal to 10. So yes, we can use the rules above here to find the upper and the lower bounds for the confidence interval. And before that, let's try to find the margin of error. The margin of error is given at the E, the big E, equals Z, which is the critical value alpha over 2, multiplied by the square root of p hat and 1 minus p hat over n. This is the formula we saw here. And we can see that Z alpha over 2 for 95% confidence level was 1.96 on the last example. Just a quick review, for 95% confidence level, that means the alpha is the order 5% or 0.05, and the alpha over 2 is 0.025. That's why when we find z of alpha over 2, we are looking for z of alpha, z of 0.025, and go back to the last example. That was the area to the right. So all you do is you take 1, subtract that to get the area to the left, and we input that 0.975 to be the area of the inverse norm from the calculator TI 83 or 84, and to get z alpha over 2 to be 1.96 from the last example. And once you get that z alpha over 2 to be 1.96 as in the last example, I can plug in here, and p hat is the point estimate, and it was given as 0.85. 1 subtract that, over n, which is the sample size of this amount of people, and altogether we get 0.0220545. This is the margin of error, and we use this to construct the confidence interval. Recall that the confidence interval is the point estimate subtract the margin of error up to the max limit of the p-hat plus e. So the two parameters, the proportion of the population, the true proportion of the population should lie between the lower and the upper bounds. And the lower bound is p-hat minus e. The upper bound is p-hat plus e. We found e here, so all you do is we take p-hat, subtract this number to get the lower bounds, or p-hat add to this number to get the upper bounds. And it should give you the decimal value, or we can convert it to the percentage by moving two places of the decimal to get to the percent. Now the question C is asking that based on the results, can we safely conclude that more than 75% of adults know what Twitter is? And the answer is yes. It appears that the population proportion is a value greater than 0.75. So at least it's 0.828, so it's already bigger than 0.75. So we can safely say that 75% of adults, they do know what Twitter is. And we can draw the figure here just to summarize everything. There's a 95% confidence level that we are looking for. We are 95% confident in this area. We are 95% confident that the proportion of adults who know Twitter is between 0.828 and 0.872. The last objective for this section is to determine the sample size. So the question might come to your mind: how many sample units n must we obtain and in order to get a good result? Now there's two cases: when an estimate p is unknown, or when no estimate p is known. Okay, and the same thing here. This should be p hat, should be p hat, q hat, p hat, and yes. Now there's a round up rule. As always, we always round up the sample size to the next largest whole number if n is not a whole number. Okay, so let's take a look at this one example here. So there are two cases. The first case is that when an estimate of p hat is known, we use a formula of this one here. And then the second case is when we don't know the value of p hat. If we don't know the value of p hat, then we assume p hat is 0.5 and q is 1 minus 0.5, which is 0.5. 0.5 multiplied by 0.5 is 0.25. Now let's try to take a look at this example, the first example. Now Gap, Banana Republic, Crew, Yahoo, and America Online are just a few of the many companies interested in knowing the percentage of adults who buy clothing online. How many adults must they do the survey in order to be 95% confident that the sample percentage is in error by no more than 3 percentage points? So we know that we want the error to be within 3 percentage point, or the margin of error, the max is 3%, and 3% is 0.03 in decimal form when we plug into this value here. Now using the recent results from the previous data, we know that 66% of adults, they buy clothing online. So in this first case, we do have some known value of p hat, which is 66% of adults by clothing online. So 66%, which is something we know from earlier studies. P hat is 66% or 0.66, and of course we can find Q hat, which is the complement of that 1 minus P hat or 0.34. And so we can apply the first formula because we know the value of P hat. 95% confidence level, which gives you the alpha of 0.05, and alpha over 2 is 0.025. And then this is just a review from the lattice sample. Z alpha over 2 is just the inverse norm of 1 minus this number to get 1.96 as before. Now the sample size should be the first formula, Z alpha over 2 square multiply P hat Q hat over E square. We got the value of Z alpha over 2 1.96 square. P hat, which is 0.66, this is some value that we got from earlier study. And Q hat is the complement of P hat or 0.34 here, and the margin of error is within 3% or 0.03 square. So that gives me around 957.8 something, and we round it up to the next whole number or 958. So we need to get at least 958 people on the survey in order for us to be 95% confident about the results. Now the next question is that we assume that we have no prior studies or information suggesting a possible value of the proportions. So how do we do that if we don't know the P hat in this case? So that means we have no idea about the point estimate in this case. That means we assume that P hat and Q hat 0.5 each, and that's why this is 0.25 when we multiply them together, and that is why we use that for the second formula here. So that is just another calculation here. The same E to be 0.03, Z alpha over 2 is the same thing, and that should give me 1067.11, and I round it up to 1068, and that is the case for the unknown value of P hat or the point estimates. Once we figure out the point estimates, the upper and the lower confidence interval limit, then we can use the formula P hat to find the P hat or the margin of error E, and that is very simple. The P hat, which is the value of the point estimate, which is the middle value between the upper and the lower limits. So all we do is we add them together and divide by 2. And then the margin of error is just the difference between the upper and the lower limit and divide by 2. So we can figure out the point estimate and the margin of error if we know the confidence interval. So the last example here is just how do we use the TI-84 plus calculator to apply to solve the problem that we just did before. So I use the same example. Recall that the previous examples, there was 1,007 randomly selected US adults that showed that 85% of the respondents know what Twitter is. Now, the sample size was 1,007 people, and the point estimate in this case is P equals 0.85. Now, find a 95% confidence interval estimate for the population proportion P. Now, if you use the TI-84-83 calculator, you should press the start. And okay, let me bring up the calculator here. So let me turn this on and clear. So how do I find a confidence interval? So press the start key, which is right here, and then click the right arrow to the test, which is right here, and move down to one proportion Z interval. which is, so scroll down here, 1 proportion z interval, and then hit the enter key. The enter key is right here. And all you do now is that you input the given information. X is the number of the observed. We know that 85% of the respondents, they know what Twitter is. This is the point estimate. And 85% of 1,077 people is 856 people knows what Twitter is from this sample, right? Recall that the p-hat is x divided by n, so x is the number of the objects, so 856 divided by the total 1007 should give me 85% for that. And then n is just the sample size, in this case 1007. We want the confidence level to be 95%. Make sure that is the decimal value 0.95. So after we input all the value here, move the arrow down to the calculate here, and then hit the enter key. So it gives you the confidence interval of 0.828 up to 0.8721, right? And that is here. So we can see that the confidence interval is from 0.828 to 0.87, and this is what we got earlier, the same thing. Let's check that to make sure that we got the same thing right here, 0.828, 0.872, same thing, but now it's much faster for us to use the TI-84 to check the answer. Now the 1 proportion z interval is just a single proportion z interval that is used to calculate a confidence interval for a population at a specific confidence level, right? So if you, in this case, we have the confidence level of 95%, so you are 95% certain that the proportion will lies within the interval that you get. And the command assumes that the sample is large enough so that we can use the normal approximation to the binomial distribution. Okay, so that is the end of the section 7.2, and thanks for watching.